Parallel lines always meet. The angles in a triangle don't add up to 180 degrees. Did I forget my geometry class? No, these are all true, but just in non-Euclidean geometry. First, let me explain what is Euclidean geometry. Euclidean geometry was invented by Euclid 2,000 years ago. He wrote a book of the elements, which laid down 5 rules, such as a line can join 2 points, a circle has a center and radius, and right angles are all equal. Euclid's 5 rules are what created all of the problems and theorems encountered in geometry. The many students suffered in the geometry class because of Euclid's work. It is considered the pinnacle of human logic, and hardly anyone will question his validity. When some begin to have doubts about his first rule, which states that from a point outside the line, there can only be one parallel line. People tried to prove it again and again, but failed. In the 18th century, some mathematicians decided they finally had enough of Euclid's first rule. They decided to create a new geometry where the first rule is no longer valid. Very strange things happened. Parallel lines always meet. Here, these 2 lines are parallel because they form right angles with the horizontal line. I'll also draw 2 parallel lines on this globe. They also form right angles. When I extend these lines, they meet. The angles in a triangle don't add up to 180 degrees. There's a triangle here. There's 2 90-degree angles already, and another angle right here. So the sum of the angles are not 180 degrees, are more than 180 degrees. Non-Euclidean geometry have curved surfaces, and Euclidean geometry have flat surfaces. People saw these mathematicians who invented non-Euclidean geometry completely crazy. And decades later, Einstein was working on the theory of general relativity. He imagined that gravity isn't invisible forces pulling us closer. Rather, it is a curving of space and time. He tried for many years to prove his theory, but failed, until one day his friend told him about a strange theory of non-Euclidean geometry. It was exactly what Einstein needed, and the theory of general relativity was born. Today, physicists continue to use non-Euclidean geometry and general relativity to try to discover the fate of our universe. Is it going to expand forever, or is it going to collapse? It depends critically on how flat the universe is. Hello, Professor. My answer of 90 on this test is correct because even though the triangle no longer adds up to 180 degrees, I was working with a non-Euclidean curved surface. Look at this problem on a curved surface. See here. Do you know even Einstein used non-Euclidean geometry?